Are your plants looking a little lackluster? Perhaps they look like this tomato and you're experiencing some blossom end rot. Do you want to give your plants a boost without breaking the bank or harming the environment? In this video, we'll show you how to make a potent, eco-friendly, homemade fertilizer with two ingredients that you have in your kitchen right now: vinegar and eggshells. That's right, those eggshells that you normally toss out can be used to make a powerful, calcium-rich fertilizer that your plants will love. In this video, I'm going to show you a step-by-step process for making this fertilizer. We will also visit with Dr. Josh Lang, who is a chemistry professor, and he is going to walk us through each step of the reaction so that we understand what's going on at the chemical level with this special fertilizer. Hi, I'm Dr. Tom Warren, and you're watching The Plant Doctor. Let's get started. So before we get into making our fertilizer, why is calcium so important? And why is it oftentimes not available to plants? So if we were to just go put eggshells out in a garden, you're not going to get the same response that plants are going to give you if you follow the steps we're about to show you. The reason is the calcium that is in eggshells is calcium carbonate, and it's not bioavailable to the plants. It's going to stay as calcium carbonate in the soil for a very long time, and slowly but surely will break down and then be available to plants. But when we add vinegar to eggs, we're going to get something called calcium acetate, and calcium acetate is readily available for plants. So why is calcium so important for plants? Well, it aids in a lot of different things for plants. Calcium is a main component of the cell walls. So when you don't have enough calcium, you lose cell rigidity. And what can happen is you see leaves begin to have what we call a parachute shape. They'll begin to bend over. You'll also see like dark purplish veins in the leaves as well. Then on the fruits, what we'll see is something called blossom end rot. And if you've ever grown tomatoes or cucumbers in an environment that lacks calcium, what you're seeing is blossom end rot. Calcium is also important for cell division, and we also need calcium to help bring other nutrients into the plant. So if you have calcium deficiency, you may see other deficiencies in plants where the nutrients are in the soil, we just can't get them in the plants because of the lack of calcium. Calcium also helps with environmental stresses such as excessive drought or heat. So what do you need in order to make this fertilizer that we're talking about? Of course, you're going to need some eggs. You're going to need a baking tray, and preferably you'll want to put some aluminum foil over your baking tray. You're going to need some vinegar. You're going to need an aluminum pan. You're going to need a couple of mason jars. You're going to need a paper bag. You're going to need some paper towels and a rubber band. One other thing you're going to need that I do not have here is you're going to need a blender. I did not want to bring the blender from the kitchen into the studio to show you guys, but I'll show you the purpose of the blender here in a minute. So these are the things that we need plus a blender in order to make this happen. So the first thing we need to do is, of course, collect eggshells. And so how do we collect eggshells? So as you're using your eggs for your breakfast or baking or whatever you're using your eggs for, you will want to keep your eggshells, but before you store them, make sure that you rinse them off. Any remaining yolk that is on the eggshell, we want to make sure that we rinse that off. Any membrane that's on the outside of the shell, we want to rinse that off as well. And this is where the paper bag comes into play. So after you rinse these off, lay them on the counter for half an hour or an hour, let them air dry a little bit, and then take them and put them in a brown paper bag. You do not want to store these in a Ziploc bag because Ziploc bags do not breathe. Brown paper bags will breathe, and the moisture in those eggshells are going to evaporate. You can also add things into the bag that'll help absorb moisture out of the eggshells. For example, you may want to put a few cotton balls down in here, and that is going to help aid with the absorption of water that may be in your eggshells. Once you've collected a half a dozen eggshells or so, what you're going to want to do is stick these in the oven to remove any remaining moisture that may be in them. We want to remove all the moisture that is located in this eggshell. So what we want to do is set our oven for 250 degrees, and we're going to bake these eggshells for about an hour and a half. Once the hour and a half is passed, the next thing we'll do is remove those from the oven and let them come back down to room temperature. Okay, so we've removed our eggs from the oven and they've cooled off. The next thing I want to do is take my eggshells and I want to break them up as small as I can with my hands. So the smaller we can get our eggshells, the more surface area that we are creating and the faster this reaction will take place. So we're going to break these down just as small as we can. Okay, so we've moved into the kitchen because this next part requires a blender and I don't want this in the studio just in case it gets messy. But you need a blender. You can use a coffee grinder, a food processor. I've got, I believe this is a Ninja model. Make protein shakes out of it. Just whatever you have on hand. It doesn't have to be a particular type or brand. You just need something that can process food. So we're going to take our eggshells that we crushed by hand earlier and we're going to put these in our cup. Let's grab these that missed the cup. And what I'm going to do here, we're going to chop these up as fine as I can. I'm actually going to mute the mic because this is really loud. So we're going to tighten this down. We're going to put this on, and about right now, we're going to mute. Okay, so now that our blending's complete, and if you do happen to have the Ninja food processor, I use the Pro extraction setting. So if you want to use the same setting, you'll get the same kind of consistency here. So let's go ahead and take a look at what we have. I'll try to get some close-up B-roll of what this looks like for you guys. And you can see here, this is a pretty fine powder. There's a few pieces in here that are a couple of millimeters big, but most of this is pretty much powder. So now that we have this ground up, we can begin to prepare our fertilizer solution. But before we do, I want to introduce Dr. Josh Lang to you guys. He is a chemistry professor. He is going to walk us through the entire chemical reaction that's going to be happening here and how this will benefit our plants. If you're not interested in nerding out over chemistry equations and how this actually works, I'm going to chapter this video so you can just skip over that part and go directly to how to make our fertilizer. But let's hear from Dr. Josh Lang.
All right, so we're going to talk a little bit about what's going on with the reaction of vinegar and eggshells if you're trying to make your own calcium supplement for plants. So an eggshell is roughly 95% calcium carbonate. And it's also got some phosphorus in there, so it's about 3% phosphorus. It's about 2% magnesium. And then we've got just a little bit of some sodium and some zinc and some manganese and some other stuff in there too. But what we're really concerned about is the calcium carbonate, because that's what's going to give us our calcium. So the reaction that we're going to see is a simple acid-base reaction. So we're going to react vinegar, which is acetic acid, so that's going to be this acetic acid, and that's going to react with calcium carbonate. And what we're going to get out of that when we react is we're going to get actually carbon dioxide and water. All right, so the products again are going to be carbon dioxide, water, and then calcium acetate. And so we have 2 of these acetates for every calcium ion that we're going to get. In solution, this is what we call aqueous. So this is going to actually fall apart in solution into ions, and that's how we're going to get our calcium that's going to be able to be taken up by the plant. This reaction is normally what we call a weak acid-base reaction, which means it wouldn't go all the way to completion. But with this carbon dioxide coming out as a gas right here, it's actually going to drive this reaction all the way to the right to completion. So all of this acid is going to react with the calcium carbonate to give us our calcium acetate. So the next thing we need to do is try to figure out how much of this stuff we're actually going to need. So we need to know how much an eggshell weighs. And an eggshell is somewhere around 7.6 grams, I believe. And so if we look at 7.6 grams and 95% of that is calcium carbonate, then we're going to get some amount of calcium carbonate. And that's what we'll use to go through and calculate how much we're going to get. All right, so when we take 95% of the weight of an eggshell, we're going to get about 7 grams of calcium carbonate. When we do chemical reactions, though, we're concerned with something called moles. So we got to convert from grams to moles. Moles is just a really big number that tells us how much of something is there. It's like a dozen or a gross or something like that. It just happens to be a really huge number. So we need to divide by the mass of calcium carbonate. How much is 1 mole of calcium carbonate? And that's roughly 100 grams. So this will tell me how many moles I've got. And that's roughly 0.07 moles of calcium carbonate. So from that, I can use this chemical reaction to tell me how much acid I'm going to need to react with that. So I'll take my 0.07 moles of CaCO3, and this chemical reaction tells me I'm going to use 2 moles of my acetic acid for every 1 mole of calcium carbonate. So when I do the math on this, I'm going to use about 0.14 moles of acetic acid, or vinegar in our case. So now we need to know how much that actually is. So this would be pure acetic acid, but vinegar doesn't come as pure acetic acid. It's going to be some fraction, so we've got to sort out what that is. So vinegar is actually about 0.85 moles per liter. So if we use our 0.14 moles of acetic acid, and we multiply by 1 liter here is 0.85 moles, then we're going to come out with about 120 milliliters of acid that we need. And 120 milliliters is going to be about a half a cup. So if we use about a half a cup of vinegar per eggshell, then we should be able to have this reaction run to completion, and we should be able to get exactly what we need out of it. If you want the reaction to move a little faster, crumble up your eggshells, make them in small pieces. The smaller the pieces, the faster they will react, and you can let this happen over maybe just a few hours.
Now that we understand what's going on at the molecular level, thanks to Dr. Lang, let's go ahead and prepare our solution. So before I came back to the studio, I took a scale that measures in grams. I measured out 14 grams of eggshell. Instead of doing 1 eggshell and a half a cup of vinegar, I'm going to do 2 eggshells, which is the equivalent to 14 grams. So we're going to put our eggshells in this mason jar. Then we are going to measure out 1 cup of vinegar. And it doesn't matter what type of vinegar you use. If you have plain white distilled vinegar, that's fine. That's what I'm using here. But if you have apple cider vinegar, it's going to work just the same. So just don't make a special trip to get vinegar. If you've got some type of vinegar in the house, it'll work. So we've got our 14 grams of eggshell. We're going to put 1 cup of vinegar in here. And while that's starting to bubble up, the remaining eggshell, this is how you can store this for a really long time. This is going to last for a few months. These eggshells can last for years. So I make solution slowly but surely, just as I need it. I'm going to take this, put a lid on it. I'm going to put it on the shelf with the rest of the stuff that I use in the yard. And as I need this, I can pull it out and make more. Now, this here, I'm going to try to get a close-up because you can see the calcium moving up and down in the vinegar here. So it's moving up and down in solution. You can see CO2 gas being released. We do not want to put a lid on this. It's not good. You can have a lot of pressure build up here, and the glass may shatter. So what I like to do is get something that can breathe. We're going to put a paper towel over the top of this. And this smells like vinegar. I don't want it in the house. So what I'm going to do is stick it in the garage for several days. And So we're just going to put a rubber band over the top of this to hold this paper towel. That allows the CO2 gas to escape. And so vinegar has a tendency to attract fruit flies, and I don't want those in the house. So here again, we're going to stick this in the garage, and also this will keep the fruit flies from flying down into our solution. A pro tip for you: as this gas begins to accumulate, you're going to see bubbles form. And the bubbles may form to the point that they'll begin to ooze through the top of the paper towel. You need something to catch the overflow with. It doesn't happen every time. Sometimes it happens, sometimes it doesn't. So for the next several days, we're just going to leave this just like this. So let's fast forward a few days and come back and see what it looks like. Okay, so it's been about a week since we have created our solution here, and it's fully dissolved. You want your solution to look like the consistency of maybe, not even milk, it's not even that thick, a very thin milk, maybe like a cheap off-brand skim milk might be the consistency that we're looking for here. But what we need to do is remove our paper towel and rubber band. And here again, guys, I want to be abundantly clear. When you do this, do not put a lid on your jar because you have CO2 under pressure here, and it could shatter the glass and it go everywhere. And we don't want that to happen. We want something that's breathable on top to release that CO2 gas. And what I'm going to do, I need just 1 ounce of this. That's all we need. A little bit goes a long way here. And so I'm going to slowly pour 1 ounce of fluid into my measuring cup. I don't want to stir this up too much. There is a little bit of solids here in the bottom, and if I stir that up, it gets into solution, and then when I go to put it in a sprayer or something, I may clog the sprayer. So if you have a lot of suspended solids still, one thing you may want to do when you pour this out is maybe get a cheesecloth or maybe a paper towel and pour it through there just to hold any suspended solids from getting in to this solution. So we're going to take 1 ounce of our calcium solution, and I have a 1 gallon jug that I use exclusively for this. So it says Ca plus H2O, calcium plus water. And we are going to take our 1 ounce of solution, add it to our water. I'm going to put the lid on it, give it a little shake so it's a homogeneous solution. And this is ready to go. So what do I do with it from here? I already have some in this spray bottle. So you can use a spray bottle. You could use a backpack sprayer. You could put a whole gallon of this in a backpack sprayer. Say that you have a garden that's full of squash, tomatoes, things that could get blossom end rot. You can go through there with a backpack sprayer and spray away. So calcium can be taken up in two ways. Calcium can be taken up in 2 ways, and it can be taken up through the foliage. So we can spray this solution liberally on the bottom of the leaves, the top of the leaves, onto the foliage. And you'll want to do this at a frequency of about every 7 to 14 days. First starting off, I would say do it every 14 days. Check your foliage, make sure that you're not burning back your foliage any, and you can increase that rate to once every 7 days. The other way to do it, calcium can be taken up by the roots as well. So we can use this to water our plant as well. So I'm using a poinsettia here just for demonstration. It's Christmas time and they're readily available. And so you can't get too many tomatoes or squashes this time of year. So we're using this as an example. So plants can take up calcium through the leaves, also by the roots, so we can spray them. You may be thinking to yourself, maybe I want to make a super concentrate of calcium water solution. I want to go 2 ounces, 3 ounces to the gallon. You might get away with doing that, but what I would encourage you to do, if you want to increase the amount of calcium per 1 gallon of water that you're doing, do it on a very small, inconspicuous spot on a couple of plants, watch it for 14 days. If you don't see any negative side effects, you can go ahead and spray the whole garden or your plant, whatever you have, with that higher concentration solution. So with just 2 eggshells, we've made several ounces of solution that will translate into gallons and gallons of calcium water that we can use in our garden. This will keep for probably 3 to 6 months. At that point, you'll want to dispose of it if you haven't used it already. That's why earlier in the video, I suggested any leftover eggshell, just keep them dry. That is much more stable than what we have here. The calcium acetate is not going to last near as long as the calcium carbonate. So this is a more stable state of calcium. Store it, just dry eggshell form, make up small batches of solution, 1 ounce of calcium solution per gallon of water, and this will greatly reduce the amount of blossom end rot that you're seeing in and around the garden. If you've used this solution in your garden and have had success or failure with it, please leave a comment about your experience down below. I want to create a community of learners here. Yes, I have a PhD in horticulture, but oftentimes I feel like I can learn from people who have been doing this for 30, 40, 50 years. There's a lot of value in experience, and I want to learn from you as well. Guys, as always, thank you for watching The Plant Doctor, and until next time, happy gardening.